All right, today we have Dirk. If you didn't know, he works here, and he's going to talk to us about HyperApp.
Wow, that was the shortest introduction I've ever had. I'm talking about HyperApp. I had some slides and I decided to ditch them and just only show you code. Why not? Actually, it's not about HyperApp at all. Is the microphone on there? Yes. Sounds like it. You can hear me? It's actually about how does a JavaScript framework work. I've always wanted to know how they work. I've occasionally opened the source code to Angular or React, and it's a lot. And so this problem always stuck with me until this summer. I found a reference to somebody who said, "Oh, I left React and now I'm doing everything in HyperApp because it's so much neater." And I looked that up and I found out it's a little tiny JavaScript framework that is the source code of which is just barely 400 lines of JavaScript. So it's like, hey, now I'm not actually planning to use HyperApp for much. It's very nice. It's great. You can use it. But that wasn't really the point of this talk. The point of this talk is like, hey, with that small framework, we can actually look at every single line of source code. Not that we're going to do that this half hour, but you could look at every single line of source code and then understand how a JavaScript framework actually works. So with that said, I'll start off. HyperApp is about 10K, 1K zipped. So your startup time of your app is like blazing fast because it doesn't first have to pump over 500 megabytes over the wire to get Angular up and running. It is like React that it has a store. It is unlike React. It supports you modify the store with actions, just like in React. Unlike React, it has asynchronous actions out of the box, so you don't have to put thunk in there and then break your head several times on understanding how thunk works. Here, asynchronous actions are very, very simple. Just in general, HyperApp tries to do everything very, very simple, and it's quite successful at that. Instead of talking some more, I'll talk you through a little application. I hope my server's still up. Let's see what it is. No, or at least you can't see it. Here's something I hadn't taken into account when I prepared this. Give me 1 second. That's not working either. Wait a second, this is not what I want. Yeah, it keeps jumping, but you keep seeing nothing, right? Because I'm jumping you from the one empty... there we go. That's looking better. Hi, audience. And in case you're wondering, here it says target div. So yeah, that's my first HyperApp app. Okay, let's see how I made that. Here it is. Only a couple lines ago. Oops, this mouse pad's very sensitive. So we import H, which we don't use currently, an app from HyperApp, and we say, an app, please create an app for me. An app has 4 arguments. I lost them out there in the comments. State, actions, view, and container. So the state is just a dictionary with keys and values. Currently, there's only one variable in our store. State and store are, by the way, the same thing. So I'll say state and store like at random times. Every odd minute, I'll say state, and in even minutes, I'll say store. So message has the value hi. Actions, we don't have any actions. As you noticed, there was nothing to click, so there's no actions in this particular page. This is our view function. Our view function says, hey, given state and some actions, which by now we know actions are empty in this particular case. This is JavaScript function, fat arrow that everybody knows. This is a JavaScript shorthand where if you only return a value, you don't have to type the word return. You leave out the curly braces, you use parentheses instead. This basically means the same thing as return, this thing. It's just easier to write that way. And we return an H1 with state message and then a space and an audience. And then that ends at stage 1. So that looks particularly familiar to this. Hi audience, right? Hi was my message and audience was the what I typed there. So that's looking pretty good. So what about that target div? Well, oh, so by the way, let me first show you that that actually works. So let's change it to Dutch because that's actually my native language. So let's do hoi instead of hi. And yes, it worked. And it was so fast you never saw it because HyperApp is very fast. So I can't move to that other screen faster than HyperApp refreshes. Let's go back to hi and show that. Oh, you can. Oh, man. The last thing that app needs to know is where do you want me to attach this? Normally we think about apps, they take over the whole page, but actually there's a whole reason to be, argument to be made. We say, actually a large part of my HTML page is pre-rendered, is already HTML, and I only render, like dynamically render with an app, with a JavaScript framework, some kind of middle part. Or even better, and I won't go into that today, you could pre-render the whole page and make sure that this app takes over certain DOM nodes. So you basically re-render the DOM nodes already in a state that is viewable to the user. For example, there's already a button there. The button isn't active yet, yeah. And only when this app actually gets instantiated, that the button that the app makes overtakes the button that you already had hard-coded in your HTML. I digress. Currently, we just want to put this thing on the HTML. So let's. I got to change this because I'm putting my own headphones on. Let's show you the HTML for this thing. Let's see where I have it. There, index.html. So what we have is a div with the ID target, and it's called target div. So, and then there's the bundle.js. This is basically, I have Webpack take my JavaScript and turn it into a bundle.js. That's just the HyperApp and my code together are minimized in the whole thing and put together in bundle.js. So this gets imported here as a script tag, which really should be in the head. I'm sorry about that. There's reasons why it's here, but for now I'm sorry about it. So here's this target div. It's called, has an ID of target, and that's can you see here. We say, hey, HyperApp, take this thing that you create, this view, and put it below the target, the div, the thing with an ID of target. So that's why in the page we still see the target div. Oh, yeah, we still see the target div, and then under it comes our content. Normally you leave this thing empty and this doesn't show up, or you make it replace, or there's all other ways to do it. But this is step one of how an app framework works. So in the end, you're just dynamically creating HTML nodes. There's easy functions for that. Let's see how that looks like. So, sorry, this is really hard to navigate this way. Should have put it on mirror, but I did it this way anyway. And there is a thingy here. I think it's this one. Collapse all. So there's only two top level functions in the HyperApp app. It's H that we come to in a minute, and it's app that you just saw. And app, here's the made function. See, indeed, it takes a state, actions, a view, and a container, just as I showed you. And this is the stuff that's going to be done. Actually, it doesn't do that much. See, it sets up some variables. We'll talk through a couple of these in more detail. It schedules a renderer because we got to render something, right? Because the user wants to see this, and it returns the wired actions. The wired actions, if you know React, is very similar a map state to, I always forget how React calls it, but basically you take your actions and they need to be kind of connected to your state. And that's what wire state to actions does. You give it a list of actions, you give it some state, and then it makes sure that every time you do an action, the state will get updated. We'll go to the detail of that in a second. But I was going to tell you how these DOM nodes get created. It's actually very simple. We have a function called, let's see where it is, create element. Here it is. As you see, this is my version of the source code. I put console logs in everywhere, so later we can see where we are. I've also done some light formatting. So in my version, HyperApp is 500 lines. The original is only 400. I ended 100 lines of exploding ternaries to if-thens, because ternaries are faster, so they chose that in the source code, and adding comments and console logs. But it's pretty close to the current release of HyperApp. So what does it do? It says, well, if an element needs to be created, and it's a string or a number, then create a text node. So this is just a HTML call that your browser supplies. You can do document, create text node, and you get a node. So this is how we map from a virtual DOM, our specification of what we want to have on the page, to actual stuff on the page. There's some more stuff going on here. You could have an SVG node, and you create this thing, and you could use another create element. I will not bother you with all the details. If there's attributes that you want on your node, then they also need to be copied to the real thing. So basically what this is doing is saying, I have a virtual DOM node, which is very lightweight JavaScript. Basically the name of this node, say h1. The text of this node, say hello audience. And any attributes, say class is, header or something. Yeah? And I'm creating a DOM node that exactly mirrors my specification in my what's called virtual DOM. Why do you do all that? Because this manipulation of the actual DOM is slow. It's tedious, it's complicated. So older frameworks, say Angular 1, used to work mostly on the DOM itself. And nowadays what everybody does is you build a virtual DOM, and then when render time comes, you create actual DOM that mimics your virtual DOM. So that's what this create element thing does. So really it's a wrapper around create text node or create element. That's really what it is, with some logic around it. Very simple. As I said, everything's simple. Let's go back to where we were. So, what about this, Dirk? There is an H1 here. That is the magic of JSX. If you know React, you've seen this before. Yeah. This is just basically Babel. The two things, by the way. Notice I do imports here, right? So all of this is ES6, and your browser doesn't understand that. So I already said that in the main HTML file, we have a script tag that doesn't refer to my index.js. It refers to bundle.js. And bundle is the converted version of my index.js. How is it converted? Well, Babel will transport, for example, transpile, import to a require statement that a normal browser understands. And it will change this fat arrow to a function statement that the browser understands. Because of a plugin that I added to my Babel, it will also spell this out to something that is much harder to read, but makes more sense. Because it's kind of interesting, I'm going to go there. We're going to comment this out. And we're going to scroll down. Let's see why we do that. Guess I'm just going to take this out. There's my new version of the app. Should be the same. Yeah. You see now, I wrote out the function just for your, so it's now, instead of a fat arrow, it's a function state actions. It returns, just now we do a normal thing, it returns an H. H in React is called create element. Yeah? And in HyperApp and all kinds of other things, they call it H. And you give it the name of your element, H1, any attributes. So this is where I would say something like class is header or something. And any children. So my first child is the state message, which is hi. And my second child is audience. So if you think about it, this creates an H1 with two text nodes under it. One called hi and one audience. And together that looks a lot like this. Hi, audience. Oh, yes?
Did you say Babel is the one that converts it from JSX to the H's?
Yeah.
Or is H is like another way you could write the code if you wanted to not use JSX?
H is another way you can write the code. That's why we imported, you can't see it anymore, we imported H from HyperApp. Babel is set up that it says whenever you see this JSX stuff, transform it into an H statement. Normally it converts it into create node statement, but Babel has a setting that you can say use the function H or use the function Dirk if you want instead. And then you can supply your own function. People use H because if you don't like JSX, you can actually create your whole view with these H functions. Some people like that, especially if you have stuff that's kind of programmatic, where you have dynamic, so you want to change these things. It's sometimes easier to use H than to use that JSX and then bend your head around whether if you type this, it's going to be. So notice it's the other way around, right? Here the JavaScript is just typed as is, and JSX you need to put curlies around it. And in JSX, if you just type something like that, here you need to put quotes around it. So it's it's doing just the other way around, and sometimes it's endlessly confusing. But on the other hand, JSX is very powerful, so I like it too. Any more questions at this point? Pretty clear how we got here? You can do this yourself? Because actually, writing a JavaScript framework is not very hard. Yeah? Okay, things do get harder, of course, from here. Because this was static and no actions were happening. So I'm going to comment this out again. We're going to look at a slightly larger app. Still fits on the screen. Yeah, kind of. Maybe not, but almost. So what I'm going to do is I have a component called counter. I'm going to have a state that has two counters, one for hours and one for minutes. And let me quickly change something. Because you want to see it first with two counters and then we'll go to one counter. Otherwise the component doesn't make that much sense. So here we have our thing. We have two counters. We have our hello audience because I was kind of enamored with that. We have an hours counter and a minutes counter. It's kind of small on the back, but I hope you can see it. Doesn't really matter that much. Basically, if I click this plus button, guess what? The number goes up, right? And only the number for hours goes up, and here a number for minutes, and I can make that go up or down independently. And end of sophistication here. If I hit 0, it gets disabled. I can't go down below 0. Wow, it's a very sophisticated app, as you understand. So what I'm going to do is, just for our pleasure, is take that second counter out of the equation now. Now you've seen I have 2. So this is my view. I return a main that basically does nothing, has the h1 that we saw before, and it has a counter component. And this counter has a name called hours. This looks exactly like React to me, and hopefully to you too. So you make a fake component. It has to start with a capital, and you give it any arguments, in this case, counter name. The counter name is only there so I can have 2 counters that count independently. So let's look what a component looks like. You have 2 types of components. This component, you could just take an argument and return something. You can also take return a function, and that's a function from state to actions. So now this component has access to the state, to the global state. You don't always want that. You can have a pure functional component. This is still a pure function. It just takes these arguments. But this one knows about the state. And of course, an ideal component doesn't even know about the state. It's pretty straightforward. It says return a div with the name counter name. Do an h3 with that counter name and the count. How do I find that count? Well, I look at state, and then under my name, the count property. So you can already see here's the state. There's a counter for hours, which I initialize at 2, and a counter for minutes, which I initialize at 10. That's how stuff works. And then we have our usual click actions. We have a down counter, and you need to know, of course, which counter you're decreasing, and an up counter. And again, you need to give it the name of the counter, because that's how I can have 2 of these counters. Pretty straightforward. Yeah. Components, basically a function, pure function, that takes in any configuration and optionally a state and an action. If you're worried about these 2 fat arrows, don't worry. Just pretend that this is a function with 3 arguments. Just the same thing. It's currying if you're familiar with that. Just looks more intimidating than it really is. So all good and well. Let's look at that again. So I've now disabled the counter. Let's look at what happens when we initialize this. We see, I'll see what I can make this bigger, because I guess you guys have a hard time seeing this in the back. Oh yes. As you can see, I didn't put on the source map. So all these references refer to the bundle, the combined source. I should have not done that. I'm sorry. I never saw it until right now. There is this nice option, source map in Webpack, when these line numbers will actually refer back to the original line numbers, because it keeps track of how that works. If you're clever, you switch it on. So I have a log HyperApp initializing. That happens here. Let's see where that was. Let's go to HyperApp. There. In our app function, so this is when we call the app function, I say, hey, HyperApp is initializing. Cool. We see that happening. Then we say render is called. And there are no lifecycle functions. I won't go into lifecycle functions at all so much today. You might see one. Basically, these are onCreate or onChange functions that your nodes can have. Just like in React, you can say, I want a certain function to be executed. This array, lifecycles, will keep track of which functions need to be called. I don't use them today in this demo, so it will mostly be empty. And then it calls the patch function. So let's go to the source and see how that worked out there. Back in the source, here we are. We have this app function. Remember, this app function calls schedule render, because once you call app once, and at that point, you guess you want the stuff to be rendered. So let's see what schedule render does. There we go. Here it is. Sorry, let me find the shortcut for that. I found it. Kind of found it. Let's try this. Yes. Schedule render says, are we not skipping the render? If so, let's set skip render to true and set the timeout and then render. What this does basically is you don't want to call render 5 times in a row, and because things take a while, then render 5 times in a row. Usually when you call render 5 times in a row, you want to render only once, and once that's done, take new calls for rendering. You want to basically debounce your rendering call. This does exactly that. This debounces rendering. The set timeout without an argument basically means do this right away, but in JavaScript it will be on another thread. I hate to say thread in a JavaScript context, but it's the easiest way to understand this. It's a different thread. So, okay, basically this says start calling render if we haven't done so already. So let's see what render does. Render says, hey, render called. Yeah, that's what we just saw. It toggles the skip render. It resolves the view. So we're going to look into that a little bit. I'm looking at the time here. Basically what this is going to do is go through our view was our virtual DOM, remember? Those are our lightweight nodes. Some of those lightweight nodes might contain JavaScript. At this point, we want to run that JavaScript to find out, for example, what that state is. So if we say in the hi audience, it took the state.message, maybe state.message has been changed. So what we're going to do is resolve all those JavaScript calls and put into our virtual DOM what that actually is. And in the end, we come up with a resolved virtual DOM, which we call node. And then we say, hey, let's patch our container, our thing. Yeah? With this was rooted here, this is the old stuff, and here's our new stuff. So that's what patch does. It says, take the DOM and update it to look like this. And indeed, that's what we saw here. That we saw that patch was called here. And with new, it said, okay, there's now a new DOM. This is the first time there is no existing DOM. The page is empty. So patch decides, oh, I got to go create new elements here. Yeah? And it says, well, let's create an element and call it main. That's that main tag that we saw around. Yeah? Let's create an element and call it h1. That's going to be our title. Let's create a text element, hello. Let's create a text element audience. Let's create a div element. Let's create an h3 under that. That's this hours thing here. Yeah? Let's create an element hours. Let's create an element equals. Let's create an element 2. This 2 is actually our counter. So this value 2 comes from our state. But at this point, it's already been resolved by that first call. So we just are rendering nodes at this point. All the resolution has already been done. Then we render 2 buttons, one with a minus and one with a plus, and we're done. Our page is up. Really simple, right? And we only call patch once, and we just create all these elements. Now, what we want to do is if I hit this button here, this needs to become 3. Yeah? And hopefully, and this will be the end of this talk, so it's perfect timing, hopefully only this 3 will be updated. Yeah? What the HyperApp and what your React and everything is trying to do, the easy way would, of course, be wipe the page and render everything again. Right? That would be the easy way to do this, no programming necessary. Regrettably, people get headaches from that because your page will flash all the time. If you remember Angular 1, it used to do that every now and then. Yeah? Pages would flash. Then came React, or other programs, frameworks too, but React made it very popular and said, with that virtual DOM, we can do something clever. We can have this whole virtual DOM that describes this page. Remember, not the actual DOM, but the virtual version. That was lightweight Java components, JavaScript components. We create a new virtual DOM, and then we're going to diff these two. And in our old DOM, it says hello audience. And in our new DOM, it will say hello audience, because nothing changed. So we do nothing. We leave those DOM nodes alone. And we keep diffing these 2 trees, and only where we see a difference, ours, the value 2 for hours, do we update only this one particular DOM node. So that's what we're going to hopefully see, that we see lots of patches and calls, but none of them will actually do anything. The only thing that the DOM node that will be changed is that one particular DOM node with the 2 in it. Let's try that. For your convenience, I'm going to clear this out. Hit the plus button. There we go. First of all, we got a set partial state. It said, well, people, I've got new state for you. Let's look at it. It says, well, I need to open this one too. We had hours, since the overstated order. The hours were 2, and the message was hello, and the minutes were something. And now the hours are going to be 3, and everything else is the same. So this is going to change our state. Remember, this is a React or Elms type environment. You can't just change the state. You need to call a function that changes the state for you. Why is that? Why do we do that? Well, if you have a function that changes the state for you, that function can make sure that we render at the moment that you change the state. And that's very important. So indeed, what happens is that function, once this update is being made, this render is called here. And it says, hey, there's no lifecycle, we're calling render. We're going to update the main function. Yeah? Okay. Main says, we're going to update this h1. You can nicely see it highlights over there. Nothing happens. We're going to update this div. Okay. We're going to update this h3. Okay. Hey, there is an actual patch. We're creating a new node with the value 3. And we're replacing that old node. We're discarding that and replacing it with a node with the value 3. And then we're comparing the buttons and nothing happens, and we're comparing the buttons and nothing happens. So in the end, what this whole virtual DOM comparison did is exactly find what we needed, that only one of these nodes needed to be updated. If I would tag any of these nodes with an ID or look at their internal reference, this DOM node is exactly the same as is this, as in that, as before the update. This DOM node, what's under my cursor here now, the one that's with a 3, that's the only one that's been changed. And that's why, even on this kind of slow, or especially on this kind of slow projector. If I do this, basically you can't see this. Well, you can see the screen wave, but you can't see the screen flicker. Yeah, because there is no update. The only update there is this particular element gets updated. Yep.
Just imagine we have tons of elements in our DOM. Is it possible to optimize this in order to trigger fire event exactly for this particular changing element, not to iterate all of them?
Ah, yeah. You say, I already know that only this. So yeah, I'll repeat the question. Thank you, Joe. The question is, hey, why do we have to traverse this whole DOM? I already know that this is the only thing that should be updated. In React, I think you can, and HyperApp certainly doesn't allow you to do that. I think there's a way in which you could do it if you wanted to, by making sub-elements. But the problem is also, even for React, it's tricky because sometimes stuff changes anyway. So you got to be very careful when you do that, because you don't really know whether this has an effect here. So the safer way to do it is to re-render everything virtually, which costs very little, and then do the diffing. And actually, the diffing is almost the hardest, the most expensive part of that. Yeah. Any more questions? Okay. Now, all I want to show you next, and that's the last thing I'm going to show you, and I'll be open for questions, is how come that render function was called. So let's real quick look at this. Remember here we resolved the node. We said, hey, we're starting to render. We take the view and we resolve it, right? Let's see what that does. Did I get there? Oh, yeah, it's here. Sorry about that. There is my resolve node. It says, hey, sorry, this is very ternary here. It says, hey, is this node a function? If so, call resolve node after you execute it. So if the node is a function, a virtual DOM node can be a function. In fact, it's a component. Yeah? My component that we saw earlier, yeah, here it is again. This counter component, that's a function, right? And you create this, well, we created it with JSX like this. So now we have a DOM node whose name is a function. Yeah? Because counter component, of course, is a name, but it also refers to a function. That means that now we have a component or a function here. And that means that when we resolve that, we want to run that function. I want to run that counter component function and do whatever. It will generate whatever view it generates. That's why we recursively call resolve node on it. Yeah? If it's not a function, well, then there's only two things. Either the node is null and we render empty string, or it's not null and we render the node. It's as simple as that. So this basically is what keeps track of all the resolving all the components. Now, the one thing I haven't shown you yet, and was promised to show you and kind of forgot about, is how come that we call the render all the time. And that's done here in wire state to actions. Looks like a lot, but it's actually not that bad. Basically what happens here is the moment that an action gets taken, we run the action. Result is the running the action on the data. Yeah? And then we call schedule render. Just kind of, here's some stuff here where we set the partial state and we get the partial state. But really what we're doing is saying, well, after you run the action, always make sure to render. You're supplying this action. That's what you do. And then the schedule render is what we do. And the nice thing is that this thing schedules itself again. So basically, after you take an action, like clicking on the plus button, it will render itself and it will schedule itself again, so that when you click on the plus button again, it will again do the same thing. So basically, these things schedule themselves. Because if you think about it, this DOM only needs to be updated after you click the mouse, after you commit an action. And that's why in a Redux kind of world, even if you have a timeout, the timeout needs to go through an action, because if you do anything else with the DOM, you don't get updates. The only way to get updates is to change the state, the store. The only way to change the store is to run actions, and that's why if once you have the actions all connected to a render call, everything will always be up to date. That's the essence of React and HyperApp. That's it. Any questions? Everybody's astounded. And yes? Is it possible to test this? As in test drive it, or?
Like test components, changes, everything.
Yeah, actually HyperApp has a fair amount of test built into itself. So the framework is tested. This component is completely trivial. Wait a second, let me show you the component. Completely trivial to test because it's a pure function. So in HyperApp, components cannot have local state. They're always pure functions. So these are, completely simple to test. Basically, you say, oh, given a certain counter name, let's give you an initial state, and then pretend that I press plus, and then my test can be that indeed the counter goes up by 1, and I can send it all kinds of actions. These are, literally totally trivial to test.
Hybrid has its own framework, testing framework, right?
It doesn't have its own testing framework, no. But you can just use Jest for this. You don't need anything special. You can just, these are functions you can call. You can use Jest to call pure functions, to test pure functions, and this will work that way. You need some data setup. I mean, you need to set up the state all the time, and you need to create these actions. But actions in HyperApp are pretty straightforward too. So, good question, by the way. Thank you.
Does it have local states? For example, if in this function before return put some variable here, and you change it inside, I don't know, different click, put another listener for click and change it. Does it render it or not?
So the question is whether this has local state. And you're right, I haven't actually tried that. You'd think... No, the answer is no, it doesn't have local state. And I'm wondering indeed what happens if I assign to a variable here. But I think the problem is because this is actually a lambda, an anonymous function, it'll be rendered over and over again. So it won't remember the name, the variable from the previous time. What you do instead is always connect to the store and use any state that you want to store. Well, use a store for that. And I must say, it makes your life a little bit easier. If you want to truly componentize stuff, so that's the drawback, everything ends up in the store. If you want to truly componentize stuff, there's a really simple trick. This app call here is just a function, right? So I can call this multiple times. I can create multiple apps. And they each have their own store, and they all talk together like microservices do. And because you don't have the overhead of React where an app is very expensive, here you can spin up 5 apps if you want and have them talk to each other. And there's actually a little extension to make that easier. Yeah.
What would make you want to choose Hyper over an Angular or React thing if you were on the project? Looking for the goals of that project that would say Hyper is better than React.
I don't think in a commercial project, well, no, I would use it. For example, I once needed a static site renderer, but then it's slightly bit more clever than that. And it had to be fast. It had to really look snappy. Now, then HyperApp is the ticket because you don't need a complex machinery. And you want something that comes up instantly. Obviously, HyperApp is going to win that from any other ones. I think you can develop serious software in it, and people have done that, serious sites in it. It's just, it's not a very standard framework. It's maintained by 5 people. I wouldn't put my enterprise eggs in this basket. But for my own hobby project, fantastic. And if as an enterprise you basically need a static site or a site that's very small and it's important that comes up right away, like for example mobile, yeah, go for it. 1K, man. It's across the wire faster than your picture, than your logo. Yeah. It's really, and yeah, as you can see, it really isn't that much code at all. It's, yeah. And it's actually pretty readable, even without my comments in it. It's, it's a lot of this nested stuff because, there's all kinds of special cases. This is the hairiest part of the whole app actually here at the end. At the beginning, it's all a lot lighter. And so, yeah, it's also a great app if you, a framework to use if you want to actually understand what your code does instead of going, and then React does black magic under the hood, and I don't know actually what's happening. Here, you know exactly what's happening. You can debug it. Which brings me to another point. I haven't tried it yet, but the Redux debugger, time-traveling debugger, works for this too, because it actually uses the same kind of actions. So if you've seen it, Redux gives you that way to debug, and that should work here completely. I haven't tried it myself. Any last questions before I all send you off into the sun? It's a beautiful day. Go enjoy it.